So in this video, we're going to talk about the idea of hydroboration oxidation reaction. So the idea is that if I take, let's do an example. So if I take this molecule, which is an alkene, and in the first step I had borane tetrahydrofuran, so this is BH3THF, and in the second step I add sodium hydroxide, NaOH, and hydrogen peroxide, I actually get this as the product. Now the idea with hydroboration is that the OH molecule, so we're really adding, it is similar to the oxymercuration demercuration reaction in that we're really just adding water across a double bond, where the OH pretty much ends up on the less substituted carbon. So that is the only difference. So again, we think about more substituted as a carbon atom having less hydrogens, and less substituted as a carbon atom having more hydrogen. So in this case, if we label this as carbon 1 and this is carbon 2, then what we're really saying is that carbon 2 is less substituted because it has more hydrogens. So therefore, we should expect that the OH molecule will end up on the less substituted carbon, right? So to make our proof, again, there is the hydrogen and there's the OH signaling H2O. So we're really adding water across a double bond. Let's do another example. If we take this molecule, can you confidently predict the products if we use borane tetrahydrofuran in the first step and then NaOH, hydrogen peroxide, in the second step? Pause the video and predict the products. This will actually be the product. Now, if we're asked to show stereochemistry, remember that hydroboration shows what we call cis addition. So if we were asked to show stereochemistry, we would show what we call cis addition. Again, this carbon has one hydrogen, whereas the carbon above has zero hydrogen. So if we label this as carbon 1, this is carbon 2. Carbon 1 is more substituted. Carbon 2 is less substituted. Therefore, we say that in hydroboration, the OH molecule ends up on the carbon that is less substituted. Now, when we say cis addition, what we're really saying is that the carbon molecule, or the hydrogen and the H2O and the OH molecule and the OH ends up on the same side. So if we wanted to show stereochemistry, we could actually write this as the methyl group going down, but again, we added our hydrogen and our OH on the same side. Or you could also write this as the methyl group going up while both the hydrogen and the OH are going down. Again, the idea is that it consists of cis addition. So both the hydrogen and the OH molecule is added on the same side. So that is the general gist of what we call hydroboration.